All right, well, let's take a look at the first one. It says find the gradient function, so we know we have to use the derivative of y equals the natural log of kx, where k is a constant. Okay, well, if we look here at this rule, it just says take the derivative of the function inside of the natural log, divide that by the original function. So we have kx, and remember, one of the rules said that if we have it's the constant multiple rule, I believe, that says if we have a constant being multiplied by a function, the derivative is just the constant times the derivative of that function, right? So if f of x, in other words, if f of x is equal to kx, then f prime x is just equal to what? K, right? And then we just follow the rule that says take that derivative, divide that by the original function. Things cancel out. And you get 1 over x. So this is important because if k is a constant, and any constant, we end up getting the first derivative function rule for a natural log of x, right? So that just tells me that our constants will cancel out. Questions? Okay, second one, a similar process for b. Let me use a different color. Okay, so it says take the derivative of the function. So the derivative of 1 minus 3x is what? Yeah, negative 3, right. It's just negative 3. Divide that by the original function, 1 minus 3x. That's it. That's the slope for, so if you graph a natural log function, you get that curve, and you want to find the slope at any point, any x value for that curve, you need to plug it into that derivative function to give you the slope, right? And remember, that's the point of all these. There are points to derivatives that will be emphasized in Unit 2 when we look at applications and the rate of change, and when air leaks out of a balloon at a certain rate, find the rate of change. We'll be looking at problems like that. It's all word problems next unit. This unit, though, it's all just straight analytical. So C, you're multiplying, so what rule do you have to use? Product rule, yep. So let's use our product rule here. First times the derivative of the second plus second times the derivative of the first, 3x squared. Okay. Let's just simplify this a little bit, do some rearranging so it looks a little bit cleaner. X squared plus 3x squared ln x. I can easily factor out an x squared, so I'm going to go ahead and do that. And that's your answer. Do we have any questions? Now the next example, you'll see probably if you've already worked on that mark scheme homework question, they have 2 methods that you could get awarded for that one. And it's because when it comes to problems like these, when we have rules of natural logs and logs, you can use them to simplify your problem, or you could use the product rule. So if you do this problem, there are 2 methods that you can use to solve it. You can use that product rule. It's going to be a little bit more complicated, okay? Because if you're going to use the natural log rule here, it says take the natural log, or take the derivative of this, which is a product, so you have to use product rule, and then divide it over the original function, which is x, e to the negative x. And I tested both ways. That will work. However, because you have a log function, remember, natural log is just log base e. Anytime you see log base e, that is natural log. You can use your rules of logarithms. How can I change this how can I express this differently? Instead of saying the natural log of x times e to the negative x, how can I rewrite that with my rules? You can move the negative x to the front if you want to. What's another way? Well, so you're taking the natural log of this entire thing. You're not raising e to this. But if I'm multiplying, can't I make this an addition problem? Can't I make this natural log of x plus natural log of e to the negative x, right? And deriving that is actually easier than the product rule because you don't have to deal with this. You know, you don't have to deal with a product. So, again, and I've shown, if you look on the key, I've shown both ways, but I'm just going to show the easier way here, just because it's, you know, if we know those rules, it can save time, and we're all about saving time in SL. So you have the natural log of x plus the natural log of e to the negative x. Okay. Well, you can find the derivative of natural log of x. That's just 1 over x. And you can find the natural log of e to the negative x, right? It's that derivative of the inside function. What's the derivative of that inside function? Well, it's e to the negative x times something. What is that something? Yeah. Yep. Here we go. Negative e to the negative x all over e to the negative x. Are you following so far? So I just derived the first part of that expression and then the second part of that expression. And so you get 1 over x minus 1. Questions? No questions? And actually, oh, Emily, you're right. You could move that negative x to the front end, cancel out the natural log and the e, because they are inverses, sorry. Or you can raise it to a natural log and cancel out, so you get rid of the exponent. Yeah, so Emily's right. Sorry about that. So there are multiple ways that you can approach this. You can break it apart and then move the negative x to the front and cancel out the natural log and the e. Or you can not do that and use your rule, but at the end you will always get 1 over x minus 1. Or you could use that product rule and you'll still get 1 over x minus 1. And actually, originally, I think I did what Emily suggested the first time I did these notes, so that's on the key as well. So just take a look and evaluate how these processes make it more simplified for you. Save your time. Questions? Okay. Now this sucker could be very complicated because what rule does it look like you have to use initially unless you split it up? You have to use the chain rule with what we know about natural logs, and I don't want to do that. If I can avoid not only the chain rule, the quotient rule. The quotient rule, right? Because you have a quotient. You have x squared divided by x plus 2 times x minus 3. So you do the quotient rule in conjunction with the natural log rule, which says the derivative of the inside over the original. That's too much work. So I'm going to save myself the grief by splitting up the function once again. If I'm dividing with a logarithm or a natural log, that means I'm subtracting, right? Now, you could do the product rule there, or you could just expand it. In fact, I think expanding x plus 2 times x minus 3 is better, but again, to each their own. You don't have to, and you can use the product rule there, and you should get the same answer. Now the first part, the natural log of x squared, what is that going to be when I find the derivative? Remember that the rule says it's f prime yeah, so it's going to be 2x over x squared minus natural log. And I'm going to go ahead and expand this. So when I expand it, it's x squared minus x minus 6, right? And then your basic rules of differentiation say to find the derivative of x squared minus x minus 6, you just derive every part of it. So 2x over x squared, we'll cancel out the x's here in a moment, minus, okay, I'm going to derive that x squared minus x minus 6 part. What do I get? Yeah, 2x minus 1, and what am I going to put that over? Yeah, over the original, which is, yeah, x squared minus x minus 6, or x plus 2 over x minus 3. Either way, it doesn't really matter. It's just a matter of preference at that point, unless something cancels out, and you want to cancel it out. We can cancel out an x there and have 2 over x minus 2x minus 1 over x plus 2 times x minus 3. I think in your book, actually, when they showed this example, they didn't combine the fractions to get this, but if you combine the fractions, you will get that as a result. This just combined it all in one step for us already, so it's fine. Any questions about this rule? Any questions about anything that we've discussed so far? All right.